Hi, welcome to Lesson 28, Cleaning Strategies. In this lesson, we're going to be looking at factors that impact cleaning regimes, how to group different cleaning items together, what are the critical cleaning parameters, worst case justifications, using cleaning agents, and the equipment and human factors. Reproducibility eliminates variability, and that's what we're aiming for in a GMP environment. The ways that we do that is to have good, strong SOPs in place. We need to make sure that people are trained on the SOPs. We need to have good, strong documentation practices in place. Our cleaning labels need to be robust, and all the documents associated with cleaning also. We need to make sure we're using the appropriate equipment and utensils for the job and that they're properly maintained. We also need to take care when we're selecting our cleaning agents to pick the most appropriate ones for the job, taking into consideration their effectiveness, but also the health and safety impacts on our employees and on the environment. We need to look at our cleaning equipment itself, making sure that it's in proper working order and that it's fit for purpose. So we want to be selective with what solvents we're using and to try and use the least amount as possible from the point of view of cost and also health and safety of the employees and also from the environmental costs. We want to try and make sure that our cleaning times are of the right duration. Too long incurs a cost, too short might mean that they're ineffective. We want to be careful about using the equipment too much to increase its utilization. If we overuse it, it might not be fit for its purpose anymore and it needs to be maintained and kept appropriately. Extension of equipment life. So we know our equipment is working in its validated life cycle. If we go outside of that, we need to verify that it's still up to the capabilities that it's needed to properly be cleaned. In a multi-product environment, we need to be especially careful of carryover and cross-contamination. We need to look out for our workers, particularly when we're doing manual cleaning and when we're using solvents or other toxic cleaning agents. And we are looking at cost effectiveness overall as well. Cleaning strategies. So instead of developing a cleaning procedure for each individual cleaning situation, similar products can be grouped together and a representative product can be selected. Groupings must be justified and documented, and it includes the following. You can group by a product. So if you're grouping by a product, the advantages are that it's the same product, so your solubility will be the same, your toxicity will be the same, the cleaning difficulty will be broadly the same depending on what you're cleaning it from. The potency of the drug remains the same, and the types, so whether you're talking about a cream or a gel, etc., will probably be the same. And you'll also have the same excipients, so it makes it easier to put a cleaning regime in place for a product grouping. Equipment grouping is an alternative way you can do it, so you can look at equipment of the same design that has the same complexity and the same functionality and design a cleaning process that will work for that. And the third type of grouping you can make is a cleaning procedure grouping. So this works particularly well where you've got an automated clean in place process or a clean out of place process, or for a manual cleaning process where your cleaning procedure is going to be the same for a number of different cleaning processes. Worst case justifications. So in this, the first thing we're going to do is list what is our worst case equipment to clean and the worst case residues to remove. We will fully validate the worst case cleaning process, and this in turn will validate the processes for easier to clean equipment and easier to clean residues. This has to be documented and rationalized. We will assess any new residues or equipment. It may be possible to add them to an existing group, or they might turn out to be the new worst case and then it would require a new validation. Worst case justifications. The worst case is usually based on a variety of factors, and these would include the product solubility in a cleaning solution. So how soluble is your product? The more soluble it is, the easier it is to clean, obviously enough, and the less soluble it is, the more difficult it is. The toxicity of the product or the respective degraded products being cleaned. So the more toxic they are, the more critical it is that they are removed. Dose sizes. So on your normal therapeutic dose size, the smaller your dose size is, the more critical it will be to validate because the more potent it is. Hardest to clean equipment. The material that equipment is made from. So for example, in the medical device industry, polycarbonate is used a lot. Sometimes this is white, so it's a lot more difficult to see residues on it. Worst interactions with the upcoming batch to be cleaned. Obviously, we need to be very mindful and aware and knowledgeable about any interactions that could take place, and that would need to be accounted for in our cleaning regime. Dead legs and piping or sampling ports or anywhere like that are areas of special concern that we need to be aware of and familiar with. We talked in our previous lesson about critical cleaning attributes, and this time we're going to be looking at, well, what are the critical cleaning parameters, the CCPs? And you can think of them as the 4 T's. Contact time, so the length of time the product is in contact with the surface. So if you think of a campaign length which might have 30 batches in it, that could take a long period of time to go through. You could be talking a week or two between each clean, so you're going to have a lot more residues. If you've got a shorter contact time, the residue is not going to be as ingrained in the process. Turbulence, your cleaning force, that can be measured either in your pressure per flow rate or for manual cleaning in the implements that you are using for the cleaning process. Temperature of your cleaning fluids. Again, that's going to be dependent on what your validated cleaning process is. For higher temperatures, they may be more effective to remove certain types of residues. Titration, this is to do with the detergent concentration and also the type of detergent that is being used. Tables of potency and solubility. When we want to select which cleaning regime we want to validate, two of the criteria we're going to be looking at is the potency and the solubility of the drug. In bracket 1 here, we've got drug A, which is a medical dose potency of 1 milligram, so it's quite potent, and its solubility in water is 10 milligrams per litre. Drug B is 10 milligrams of potency and 20 milligrams per litre solubility, and drug C is 100 milligrams and it's 30 milligrams per litre in its solubility. So I'd just like you to take a minute to look at bracket 1 and bracket 2. Which products do you think that you should use for the cleaning validation exercise? For bracket 1, we're going to be looking at drug A, because drug A is clearly the worst case scenario. It is the most potent of the drugs in the table. If we look at bracket 2, we've got a 10 milligram dosage, 15, 20, 100, 200 and 500, and our solubility in water is 20 milligrams per litre, 100, 150, 200, 500 and 1 milligram per litre. So for bracket 2, we're going to be looking at taking drug D because it is the most potent of the drugs. But also we are looking at drug I because it is the least soluble of the drugs. So we're taking the worst case scenario for solubility and for potency, and we will probably validate both of these. Cleaning agents. So the cleaning agent that we select is vitally important to our cleaning process. There are different types of solvents and agents you can use. The first type here is organic solvents. Organic solvents are used a lot, particularly in the active pharmaceutical ingredient in the API industry. You would see acetone and methanol being used quite an amount. The considerations for using solvents are the cost of the recovery. Obviously, there's a big expense involved in using solvents. We would also need to consider the safety implications of that, as using solvents has an increased risk of health and safety in terms of the environment and also in terms of the operators who are using it. Reflux is going to use organic solvents a lot as well. The solvent will be charged to the vessel and is heated to boiling. The vapour then can reach difficult to reach areas, so like your distillation column and your condenser. Chemical cleaning. This is where we're using a chemical reaction, so acids or bases, to remove our residues. So salts that are built up can be removed using an acid or basic clean. We want to move towards using more environmentally friendly acids, so things like citric acid, as opposed to using like phosphoric acid, phosphate waste, so from an environmental point of view and also from a cost concern. Aqueous cleaning agents and surfactants, so something that is a water-based solution. Choosing the correct cleaning agent. So chemists will often recommend solvents, that's their area of expertise. We need to remember that we should always use dedicated equipment when manufacturing difficult to clean or toxic products. Products which simulate the physiochemical properties of the substance to be removed can be used instead of the substances themselves, where such substances are either toxic or hazardous. Equipment. When we are doing up our user requirement specification upfront is the time to be thinking about how you're going to clean this piece of equipment, and that should be an important consideration for you. So the design of the equipment needs to be checked and examined. Critical areas should be identified, so in reactors, areas that the spray ball might not be able to reach, any difficult to clean areas that you need to be knowledgeable about where those critical areas are and how best to clean them. Dedicated equipment should be used where you have a difficult to clean or when you're using manufacturing products that have a very high associated risk with them. Equipment must be stored in a dry condition after cleaning, so we don't want any stagnant water present because that will give rise to microbial growth. Equipment cleaning challenges, so manual cleaning. Questions that are worth considering. when you're developing cleaning methods. When is a piece of equipment clean? At what point can we stop cleaning? What is the definition of visually clean? Will all operators have the same understanding of it? Does the equipment need to be manually scrubbed, and what does this achieve in comparison to using a solvent wash? How variable are manual cleaning processes from batch to batch and from product to product? We obviously want to have the least amount of variability as possible. What solvent or detergent is appropriate to use, and at what concentration? Are different cleaning processes required for different products, or can we use the same one? And that cuts down on mix-ups caused by operator error if you've got lots of different SOPs and different cleaning procedures for different equipment around the site. Must a cleaning process be applied more than once to make sure that the cleaning has been adequate? Changing suppliers. So raw materials are sourced from different suppliers occasionally, and they may have different physical properties and impurity profiles depending on where they have been purchased from. Such differences should be considered when you're designing your cleaning procedures, as the materials may behave slightly differently, and that should be captured in your change control if you're changing materials. Human factors. Visual inspections for cleaning. We mentioned already there needs to be a very detailed SOP to make sure that everyone has the same understanding of what visually clean is. Swabbing is really important. Operators must be trained for swabbing, and in a lot of cases they would be expected to be certified to make sure they are taking the swabs in the right way and it's consistent across the site. We need to have specified about our hold times. So we would have dirty hold times, how long you can leave a piece of equipment dirty before it's cleaned. Obviously, the longer that it's left, the harder it is to clean. We would also specify what is our clean hold time, how long you can leave equipment exposed after it's cleaned, before it's used or before we would need to re-clean it. And our campaign length. Obviously, if you have a campaign length that is 30 batches, your residues are more ingrained in it than a batch length that might be, or a campaign length that might be 2 batches long, depending on the time. So it would be more difficult to clean, and that would need to be considered. We want to limit human interaction with the cleaning cycle as much as we possibly can by introducing automation where it is possible to do that. SOPs and training are critical for manual cleaning. You need to make sure that there is consistent cleaning across the site between operators. And the best way to do that is to have a very robust SOP and a very robust training system. References for you. Steris Life Science, their website has a lot of really good information in their educational page, and it's worth having a look at it. Over to you. How can cleaning processes be grouped? What are the 4 critical cleaning parameters? Thank you very much for your time and attention. We'll see you